Rise and shine, friends. I welcome you to the basic probability part 3. So, starting off with mutually exclusive events. As the name suggests, what is mutual meaning? Like the meaning of the word mutual. It is like आपस में. Okay, mutually means आपस में कोई चीज़ का contract होना किसी का. Okay, and what is exclusive? Exclusive means कोई दो चीज़ें जिनका लिंक ना हो. So mutually exclusive, summing up these two terms together will give me something which has no mutual, relationship between them. Okay, like two things which have no mutual relationship are mutually exclusive things. Okay, and talking here of mutually exclusive events, so there will be two sets which have no relation with each other. Like they are all solely dependent, we can say this. Okay, so a and b clearly you can see have no links with each other, so their intersection is phi, like they have nothing in common, hence the probability of their intersection is 0. Hence we can conclude that the formula will be framed this way, like the formula of their union is probability of a plus probability of b minus probability of A intersection B, but here in this case this value of probability of A intersection B is 0, so the formula will be like left out by simplifying this one only. You can clearly see if this rectangle is my sample space and there are two events A and B which have no links together, is a mutually exclusive event. The example is like if I'm talking about the marks in the class of students, so I am making a set A in which the marks are from 0 to 40, like the students who got marks from 0 to 40, this is a set A suppose, and this is B in which the marks are from 60 to 85. But you can clearly see like this is the not all the marks students can get, like there might be a case a student who is getting marks 50 or 51 or 52 which is not there in the set A nor in the B. Like there must be other cases as well possible which are except 0 to 40 and 60 to 85, like the range is from 0 to 100, and in this the area remaining from A and B is left out, of course, which we can see is this part which is not included either in A or in B, right? So इसमें A and B के बाद भी कुछ काफ़ी एरिया लेफ्ट है. Clearly you can see this is a sample space, the rectangular sample space in which A and B are two sets, and apart from the A and B I have the empty area left out. Okay, so this is something which we call as like define as mutually exclusive events. Why I am like making it an emphasis on the area left out, you will get to know it in the second part which we are going to discuss of mutually exclusive and exhaustive events, because this is very much related to the first part. It is same as first part, but the condition here is there is a set A and a set B similarly like we have in previous one, but here the condition is इसमें A and B के बाद कुछ भी left नहीं है, like there is no empty or space left out after distributing something in A and B. This is also a sample space of a rectangular like uh, distribution like that way, but there is nothing left out, so I can say that probability of A plus probability of B will give me total 1. I have told you that study probability in terms of area, and the area you will consider here is 1. So as the the upper limit of the probability that cannot exceed 1, that is why I am taking it as 1. So the union will sum up and give me 1. Here you can take the example of the distribution of marks from 0 to 40 and 41 to 100. Here you can clearly see no marks distribution from 0 to 100 is left out in this case, like everything is included. So इसमें A and B के बाद कुछ area left नहीं है. This is very well explained and you will get to know of it. You can make the note of all this thing. Nextly, then we'll move on to independent events. As the name suggests, independent, like there are two events which don't have any dependency on each other. Like one is not dependent on anything. Like occurrence of one event does not affect the occurrence of some other event. So in this case, our condition which will be applied is the probability of A intersection B will give me the individual product of the probabilities of A and B, like the probability of A into probability of B. Please make a note of it. This is very important and going to be in use very much if you will solve numerical examples. Okay, moving on to some notes. Every mutually exclusive events are dependent. Okay, mutually exclusive events which we have studied upwards, they are dependent. Okay, they are not independent events. Please make a note of it. Second point I have is unconditional probability. In the part 2 I have taught you conditional probability, in which I talked about probability of A given that B has already occurred. I have also given a formula to you of that. So here we are talking about unconditional probability. The perfect example that will define and that will explain you this is the probability of death. We all know death is a universal truth, and the probability of death is 1, which is the perfect example to define an unconditional probability. Okay, thirdly, we have the point that conditional and unconditional probability will give me same answer when events are independent. Okay, so conditional and unconditional, both the probabilities, for both the probabilities the answer will be same when the events are independent. Okay, so please make a note of all these things. Now we are going to discuss some probabilities, what, like they are all conditional probabilities. As you can see from the sign, condition is applied, but the cases of independent events, like both, there are two events A and B, both are independent, they don't have any dependency, like the occurrence of one will not affect the occurrence of second event. So I am saying they are conditional probabilities, but they are independent, like the occurrence of one is not affecting the occurrence of second. So, and we know in conditional probability the condition is that the probability of one when the other event has already occurred, but occurring of the other event is not mattering to me in this case. That is why in all the cases the probability of the upper one, the numerator, will only be the answer. You can see clearly from here, like probability of A naught given B has already occurred will give me probability of A naught only, because although it is given that B has already occurred, but it is not affecting to me in this case as the events are independent. I hope you have understood it. Please make a note and do hit the like button if you have learned anything new today. Thank you so much for being a patient audience.